this on test day was important to me. I thought golfing was the next day.
Your boy. Just like sorry, your boy shot his first 90.
Okay, all right. Now, I'm going to answer questions about any, did you take it all the way around? About
That's like
any
good.
homework. I returned everything, you have everything. So homework, review sheet, whatever you got. The only thing on the review sheet is, please do not ask me if you haven't tried it. Your job is to do some work. If you didn't do it, I'm not doing it. If you tried it and can't get it, I will help you through it. But I need you to invest in the review process. All right? So, who has found something that we need to review? Brooke.
Can you do number 16?
On the review sheet?
Yeah.
Number 16 on the review sheet. We're going to remodel. All right, let's read it. Sue, Esther, and Murphy working together. Did I do this from last time? I didn't? No? Okay. Must have been the other class. They all ones together in my brain. All right, so working together in the room in 4 hours. Sue and Murphy. Okay, how long would it take each of them to paint the room alone? So I'm going to let, there's too much to keep track of, so I'm going to let my variables be S, E, and M, and S stands for Sue's time alone, E stands for Esther's time alone, and so on. Is that okay with everybody? So I know that if they work together, so 1 over S plus 1 over E plus 1 over M will be a fourth of the job. If they work for 1 hour, they will complete a fourth of the job. All right, Sue and Murphy can do the same room in 6 hours. So Sue and Murphy in 6 hours. And Esther and Murphy in 7 hours. So Esther and Murphy in 7 hours. Now, I want you to think about this for a minute. If I hire Sam to paint the room, and it takes him, let's say, 8 hours to paint a room, how much of the job will he get done in 1 hour? 1/8. So if it takes Sue S hours to do the job, how much will she get done in 1 hour? 1 over S. So all of these fractions are 1 hour's worth of work. And I know that in an hour, a fourth of the room will be painted, because that's what it tells me, right? Now, I have a system of equations, but it's kind of messy because it's not regular variables, it's 1 over the variables. So, if you look at this, I mean, look at something here. What do we know about that? What do we know about 1 over E plus 1 over M? It's 1/7. So can't I just take that top equation and write this? Would you agree? I mean, that would be the easiest. There are lots of ways you can solve this. Substitute, eliminate, put in your calculator, whatever. Substitution seems easy here because it's just kind of set up that way. So 1 over S equals 1/4 minus 1/7. So I'll get myself a common denominator here. So 1 over S equals 3/28, which means S equals 28/3. So it takes Sue 28/3 hours, almost 9 hours to do the job, or a little over 9 hours, I guess, to do the job. Okay, now let's come back here and let's do the same thing. We know 1 over S and 1 over M. Oh, actually, we got a couple different options, but we know 1 over S and 1 over M adds up to a 6. So can I say 1 over E plus 1 over 6 equals 1 over 4? This guy and this guy are 1/6. So 1 over E equals equals 1/4 minus 1/6. I got 1 over E equal to 1/12, so E is 12 hours. And then I gotta find M, so I'll just use this one. 1 over 12 plus 1 over M equals 1 over 7. So 1 over M equals 1/7 minus 1/12. 5/84. So M equals 84/5. All right, who asked me for that problem? I can't remember. Brooke, you got it?
Yep.
Yep. Now again, how you actually solve it is up to you. There, you have options. I substituted and stuff. All right. Who found something else as you were preparing for a test? 13. This is one of the bigger determinants. So if we're playing it smart, and it is a test, you are under a time limit. So I'm anticipating that you would want to be efficient. You're going to look at your determinant and you are going to choose the row that has the most zeros. Well, there are 2 rows that have 2 zeros in them, right? Doesn't matter which one you use. I'm just going to use the second one. It doesn't matter. We're picking a row that has the most zeros. If there's a tie, just pick one. All right, so I'm going to choose this row right here. So I'm going to write down 2 and -1. Those are the only 2 numbers I need to write down. I don't need to write down the zeros. Now, same, change, same, change. So that's going to stay the same, and this one's going to change to a +1. Same, change, same, change. Now I'm going to wipe out that row because I'm done with it. I won't use any of those numbers anymore. That 2 is this 2, so I'm going to cover up that column. And the 9 numbers I have left are going to form this minor determinant. So 1, 5, -1, 3, 0, 4, 1, 6. Hopefully I copied that correctly. Then that 1 is this 1, so I'm going to cover up that row or column, cover up this column, and take out or write down the 9 numbers that are left. Okay, now are you with me? All right, then I just recopy my columns. I evaluate this. So 1, 5, -1, 3, 0. So here we go. There's a 0, -3, 0, 0, 0. Ooh, 90. Now what do I do with those 2 numbers? Subtract. So -3 minus 90 is -93 times 2 is -186. So the value of this part of the problem, not the answer to the question, but the value of this is -186. Now this one. $18, 0, 0. -12, 0, 0. Subtract and get 30 times 1 is 30. What do I do with those 2 numbers now? Add them. So the answer to the problem is -156. That's the determinant value. you should get that answer no matter what. No matter what row you used or how you did it. All right, who else has a question?
Number 7.
On the review sheet, number 7, solve using the inverse. Now, this is a calculator problem. By the way, I've done 2 problems so far, and each one of them has pretty much taken the whole board. So don't be alarmed when you get your test and it's 6 pages long. It isn't that many problems, it's just they all take so much space, right? So we're not gonna be alarmed when that happens. All right, so I'm using the inverse and I'm using my calculator. So when this is the case, you have to write down everything you're putting into the calculator. So if you're using the inverse method, you are putting that matrix, the matrix of coefficients, you're putting the constants in, and then you're gonna multiply A inverse times B, and that will give you your answer. That's all there is to it. Just type it in on the calculator. So second matrix, edit, 3 by 3. I got 0.5, negative 2.5, and negative 2.5. Now, on the test, I didn't necessarily rig everything, so I have put no decimals, because I don't want anybody getting these wacky decimals around you all. These aren't bad decimals, but I put no decimals. So we'll just go to our calculator, hit math frac, and it will give me the fraction form. Of the answer. It's X, Y, and Z. Okay? Because if I don't rig it, you don't get answers like this. You remember, we've seen that before. You get wild and crazy things. Huh? Yeah, that's what we learned. All right. Sam wants to do the Gaussian elimination problem from your quiz. All right, so hopefully I've copied it right. Okay, so here we go. We're doing Gaussian elimination, so this will be on the no calculator part. I just got a calculator. You know, the first thing we need to do, by the way, have we all taken a quiz? Anyone this year? Good. Okay, so we gotta put a 0 here and here. That's our first goal, to put zeros there. So I'm going to multiply the top row by negative 3. And I'm gonna add it to the second row. So that gives me 0, negative 1, 16, and 61. Now I'm going to multiply the top row by negative 4. So negative 4, negative 12, 20, and 44. All right, let me double check. Negative 4, negative 4, negative 4, negative 7. All right, and add it to the bottom row. So I get 0, negative 14, 14 and 34. Is that okay with everybody? I need only one more zero. I need one more zero to be right here. As I am copying down my second row, remember, I'm done with my second row. I'm not putting any more zeros there. The only zeros coming right here. So I've rewritten my first two rows. I went ahead and divided this one by a negative because in the end, my matrix has to be in row echelon form, which means that needs to be a positive 1. You do not have to do it now. You can do it whenever you want, but in the end, that has to be a positive 1. All right, so to get my 0, I'm going to times this existing row here by negative 14. This row right here by negative 14. So I get 0, 14, 14 times 16, I don't know that. So I'm going to have to multiply it. 224, a negative. And, oh gosh, 61 times 14. 854. And that would also be negative. All right, so now I'm going to add, and I get my 0 and my 0, just like I wanted. Negative 224 minus 19 would be negative 205. And this one's going to be negative 820. That matrix is not in row echelon form, but I can tell what my answer is going to be, at least in the beginning. But I'm going to go ahead and put my matrix in echelon form. So I follow the directions.
So if we don't put that last one, like.
I said you could on the quiz, but we're going to be precise on the test. If it says Gaussian elimination, row echelon form is your answer. All right, so it takes you half a second, just recap. Now, what does that bottom row tell me? Z equals 4. So now I know Z is 4. So Y minus 16Z equals negative 61. So Y minus 64 equals negative 61. So it looks like Y is 3. And then X plus 3Y minus 5Z equals negative 11. So X plus 9 minus 20 equals, I got X equals 0. So my answer is 0, 3, 4. So if you miss that problem, you have to make a distinction between arithmetic or I don't know what I'm doing. If you don't know what you're doing, this is bad. But if it's arithmetic, just be careful, right? Just be careful. I do not want you to think, though, that every time you do a problem like this, you're going to get a nice, neat answer. Because, again, I've been really busy lately, and I haven't had time to rig all this crap. So don't be alarmed tomorrow if things don't come out perfectly. Do what you do, and if it comes out as 5/7, it comes out as 5/7. Huh? It happens. Now, 51/54 would actually reduce, so you'd want to reduce that. Reduce this by 3, I think. Yeah. All right, come on, what else? There has to be something else we need to review.
Number 14 on the review.
14 on the review comes Charles's golden toners. 14 on the review. Now, keep in mind, what what's the equation of a parabola look like? In big, not specifically, but in big picture, it's a quadratic. So what we're really doing is writing this equation. That's what we're coming up with, that equation. You have been given 3 points. Those points are x's and y's. So one at a time, I'm going to plug them in. So 6 equals 4a plus 2b plus c. I put 6 in for the y and 2 in for the x's. Then 31 in for the y and 4 in for the x's. And 4 in for the y and negative 2 in for the x's. Okay? Now, it doesn't say how to do this, so you can do this on your calculator, however you want. If you decide to do Gauss-Jordan reduction, though, be careful. The 6 belongs on this side over here, right? So you might, if you're going to type it in the augmented matrix form and do RREF, Gauss-Jordan reduction, then you want to move these constants over here to the other side. So type it in, RREF it, up's going to come A, B, and C, and plug A, B, and C into your equation, Charles, and that's it. So like y equals 5x squared plus 9x minus 8, or whatever it comes out to be.
Can we do it by elimination too? Or do we have to do the RREF?
Well, you can do it however you want.
Okay.
Yeah, you can do it however you want. Because if you want to, you mean like manually eliminate,
Yeah.
that's up to you. That's fine. On a calculator part, you can always do it by hand if you would prefer.
So it will be on the calculator.
Yes. The only ones of these that aren't on the calculator, big ones like this, the equations for unknowns, are the ones that say Gaussian elimination, like we practiced on our quiz. Now, I remember there was a homework problem. I don't remember what one it was, but it was like this, and a lot of you missed it because you didn't pay attention to the directions. The directions in the homework said, write the equation of the cubic polynomial. And a lot of you tried to set it up like this. No, this is a quadratic polynomial. If this were a cubic polynomial, you have to use this formula. Right? You do it the same way, plugging your point in. All right. Who else found something you have a question about? Hey, what are you back there doing?
What?
What are you doing back there?
Go through my old.
Okay, as long as we're focusing, we have a test tomorrow. Mallory,
11M.
on 11M, like in Mallory's. All right, this one says find the inverse of matrix B. You can't. Why can't we find the inverse of matrix B? It's not square, can't find the determinant. So if a matrix doesn't have a determinant, it's not gonna have an inverse. And if it's not square, it does not have a determinant, so that would not be possible. Remember, there are lots of ways these could be no answer. Remember, you can't just add, you can't just multiply, there are rules you have to follow, right, Eric?
Can you do N? We'll let him
N, have you tried it?
I just forget how to write it.
Oh, well, what should we do when we forget, Mary? Sophomore Mary, what should we do when we forget? Look in our notes. Answers are always in our notes.
She'll learn when she's a senior.
Assuming she's still coming to school when she's a senior. That seems to be a problem for our seniors. All right. We're
I'm
gonna
your dog.
reflect matrix A
This kid's going.
across the X axis. Now, I am not giving you any of the transformation matrices. So you're gonna have to know how to reflect and how to rotate. But it's easier than you might think. Oh, I can't memorize all that. Don't memorize all that. What you memorize is that this is the beginning of everything. That's the identity. And this is vector I, which is associated with X, right? And this is vector J, which is associated with Y. So this is the X component, and this is the Y component, right? Now, if I want to reflect across the X axis, so here's a point. If I want to reflect it across the X axis, aren't I doing this, putting it down here? So what changes? When you go to the other side of the X axis, what changes? The sign on Y. So you come back over here, this is the X component, this is the Y component, change that one, and that's your reflection matrix. Okay? So we just take that matrix, and we multiply it times the pre-image, the one they gave us. Remember, when we multiply, we take first times first, second times second, it's this row times this column, so -1 and 0, 4 and 0, 0 and -3, and 0 and 0. There it is. That's it. Okay, Mary?
Sounds good.
Obviously, if we were reflecting across the y-axis, then we're going to change the sign on X. So that would be a reflection across the y-axis.
In the origin of the whole.
Yes. Mallory?
What would you do for like y equals -x?
Well,
Would you shift?
think about, go back to the original. First of all, if y equals x, that means they have switched places. So they're gonna have 0, 1, 1, 0. And if we've negated it,
So with just that, then are they both ending?
yep. All right. Okay, so when we come back from lunch, we are going to do a few notes, beginning chapter 9.